I'm going to look here at an object suspended from wires. In the first situation, the object is fixed to the wire, and in the second situation, it's suspended by a light ring which moves freely along the wire, and that makes a difference to the tensions. So in the first situation here, I've assumed that the two tensions are different, and I've marked on the weight. I've resolved T1 into its vertical and horizontal component and done the same with T2. And now I'm going to set up some equations. So first of all, horizontally, there are only two forces, so they must balance each other. T1 cos 40 to the left, T2 cos 40 to the right. Rearranging that, I get an expression for T1 in terms of T2 and cos. So now vertically, I have three forces. So T1 going upwards at T1 sine 40, T2 sine 30 going upwards, and then 5g going downwards, which balances. So I already have an expression for T1 here, so I'm going to substitute that in, and that's all I've done in this next line here. Now you can see that I have a factor of T2 in each of these terms, so I'm going to factorise that out. So I factorise that out, leaving this here and this in the bracket, and now I can just divide each side by this whole expression here. So 5g divided by this gives me in my calculator 39.9. Now I put all of this exactly into the calculator so that I don't lose any accuracy for my final answer. So what happens when the wire is freely moving? Sorry, the mass is freely moving. So here the tensions in the string now are equal to each other because it's not fixed to the wire. So I've resolved again using the new angles, because these angles would be the same, the pendant or whatever it would be if it was on a necklace or something suspended from the ceiling would work its way towards the middle, and these angles would be the same. So you can see that if I resolve, if I make an equation for the components in the horizontal direction, I get t cos 35 equals t cos 35. Well, the t's would cancel out, so that's not very helpful. So I can only really resolve vertically here. So I have t sine 35 plus t sine 35, which gives me 2t sine 35, balancing out with 5g. Then rearranging, I just divide both sides and get 42.7. Now how does this change from when the wire was fixed? So you can see that when the wire was fixed, the angles were 40 and 35, and they're balanced out to 35 each. But the values, one tension was 39.9 and the other one was 45, and we've worked towards the halfway point of those two as we would expect.